In this video, I'm going to show you how to find equations of quadratics given particular information about the graph. So in example 1, it says use the vertex hk and a point on the graph to find standard form of the equation of the quadratic function. If you recall, standard form looks like this. Right, h and k is your vertex, and then a tells me if it's facing up or down, concave up or concave down. Okay, so they give us in this problem, they give us the value of our h and k. That's our -2 and 4. And then they also give us another point on the graph, -4, -4. That is any point on the graph, not a specific point that is key to the graph like hk, like it's a vertex, but it's just a random point that they picked off the graph. So what we're going to do is we're going to plug in hk because for sure that is part of the problem or part of the equation. So in order to put this in standard form, I need 3 pieces of information. I need my a, I need my h, and I need my k. And right off the bat, we already have 2/3 of the problem done because they give us what h and k is. So I'm just going to go right ahead and plug in our values of h and k. H is -4, so since there's a negative in the formula, I'm going to have a double negative, which is going to make this a +2. And then my k is 4. So the only thing left I have to find is my value of a. Now, the second piece of information that they give us, this piece right here, is going to help us find our a. All we have to do is plug that in for our points, for our x and y, and we can figure out what a is. So I'm going to plug in -4 for y, -4 for x, and then I can solve this for a. Now, one thing that I want to point out that a lot of people make this mistake, so be careful. Remember order of operations here. You want to do the inside first, and then you square it. So -4 plus 2 gives me a -2. And then when I square the -2, that gives me a +4. So I get -4 is equal to 4 times a, right? I get a times this, and this came out to be 4. And then I have +4. I'm going to subtract 4 from both sides so I can solve this for a. So I get 4a is equal to -8, which means a is -2. So I have my a now. My a is -2. So we're done. So my final answer would be -2 for my a, x plus 2 squared plus 4. So here is my equation in standard form. So just to recap real quick, they gave us the h and the k. We need 3 things to put it in standard form. We said we need the a, the h, and the k. They gave us the h and the k. We plugged that in, and then we used the extra point they gave us to solve for a. Once we had a, we had all 3 pieces, and we can write down our final answer. Okay, same idea here. We want to put it in standard form. They give us the h and the k and an extra point. So in order to put it in standard form, I need to know what my a is, my h, and my k. They give us the h and the k, so 2/3 of the problem is already done for us. I'm just going to go ahead and plug that in. So I have y is equal to a times, my h is 3, so I have x minus 3 squared. My k is 0. If you don't want to put it in because it's 0, you don't have to, but I'm going to write it down so that you can see where it came from. So that's my k. Now they give us an extra point, 0, 12. That's what we're going to plug in for x and y, so then we can use that to solve for a to get our last piece. So I'm going to plug in 12 for y. I'm going to plug in 0 for x. I'm going to finish this over here. I have 12 is equal to, I do inside here first, 0 minus 3 is a negative 3. When I square negative 3, that gives me a positive 9. So I'm left with 9a. And then I have a plus 0, but this time I'm not going to write it in. Now I'm going to divide both sides by 9, which I can reduce that to 4/3. So my a is 4/3. So my final answer is going to be y is equal to 4/3. That's my a. Then x minus 3 squared plus 0. Okay, the next example, we're going to write the equation of this graph. We're going to do the same thing we did up here. Only now we're given it in graphical form instead of literally writing down the values that we need. We just have to get the values off the graph this time. So if we want to write it in standard form, we need to know our h, our k, and our a. Well, we can get the h and the k just by looking at the graph. Our h and k is our vertex. That's this red point right here. So my h is -2 and my k is 2. So I'm going to go ahead and plug that in. I have x minus a -2, so that's going to give me a +2. And my k is 2. Now I got to just pick another point on the graph. It doesn't matter which one. Pick another point that's not the vertex and plug it in for x and y so you can solve for a. Now you can pick any point, but my suggestion to you is to make things easier. Whenever you're given an opportunity to pick a point that has 0 in it, it makes the arithmetic a lot easier. So the additional point that I'm going to pick is 0, 0 for my x and y. But I could have picked this point here. I could have picked this point here. This point here. It doesn't matter which one I pick. I just got to pick one off the graph. I'm just picking the origin because it will make it the arithmetic easier. So I'm going to plug in 0 for x and y. So I have 0 plus 2 when I do the inside first. 0 plus 2 is 2. 2 squared is 4. So I have 4a. So I have 0 is equal to 4a plus 2. I'm going to subtract 2 from both sides. So when I divide by 4 on both sides to solve for a, I'm going to get -1/2. So my final answer is going to be y is equal to -1/2. Then x plus 2 squared plus 2. Now, if my a came out to be positive, this is where bells should go off and you say, wait a minute, something is not right. And that is because if you look at the graph, this is a concave down graph. It's a frown shape, so I know my a should be negative. If my a came out to be positive, that's when I know I made a mistake somewhere and I can go back and double check. Okay, now we're going to do the same thing, but now we're going to use a table instead of a graph or specific information just handed to us in the problem. So it says use the table of values that represents points on a graph of a quadratic function, determine the vertex and the axis of symmetry, and then find standard form of the equation. Okay, so we need to put it in standard form. So if I look at this, I start at -2, I go up to 0, and then if I look at the corresponding y values, I go down to -2. -2 looks like my lowest point, and then I start to go back up again. So by looking at these points, I can see from -2 to 0, I'm going down, and you can graph the points on graph paper to check too, if you'd prefer to do that. So from -2 to 0, it looks like I'm going down, and then at 0, -2, these values start to go back up again. So it's going to be concave up. My vertex is going to be 0, negative 2. Now I've got to pick another point on the graph, an x and a y, so I could figure out what a is. It doesn't matter which one. I will pick, let's say I'll pick negative 1, negative 1. So I have y is equal to a, and then I have x minus 0 squared minus 2, and then I'm going to plug in my negative 1, negative 1 for my x and my y, so that I can solve for a. So inside the parentheses, I got negative 1 minus 0. Negative 1 squared is positive 1. So I have a negative 1 is equal to 1a minus 2. Because inside here, I get a positive 1. Negative 1 squared is a positive 1. Then I'm going to add 2 to both sides so I can keep solving for a. That's going to give me a positive 1. So a is 1. So my final equation is going to be 1 in front with my a, and then x squared. And if you want to write in the minus 0, that's fine too. And then minus 2. Now, the last part I didn't talk about yet with you. It says to also find the axis of symmetry. And the axis of symmetry is just the vertical line that goes up through the vertex so that it splits the graph in half so that it looks like a mirror image on each side. So this would be my axis of symmetry. It's the vertical line that goes up through the vertex. And remember, vertical lines have the equation x equals, and then whatever value of x it goes through, so that all your y's change, but your x's stay the same. So my axis of symmetry, since it goes through x is 0, my axis of symmetry is going to be x equals 0. And all that tells me is if I had a point over here, whatever this distance is from here to here is going to be the same distance over from the center, from the vertex, from the axis of symmetry out to the other side of the quadratic. So if this was a piece of paper and I were to fold it on the axis of symmetry, it would line up exactly on both sides of that paper when I fold it over. Okay. The next question, same thing. We're just going to practice. I have the point negative 3, 3. It's going up negative 2. And then it's going to go back down again. So this is going to be my vertex. So I have the point, if you can check it on here if you want. I have the point negative 3, 3. Negative 3, negative 3. And then I have the point negative 2, negative 2. And then I have the point negative 1, negative 3. And then it starts to drop again. So it's going to look like this. So this is going to be my vertex. So my h and my k is going to be negative 2, negative 2. So I just have to pick another point to plug in for x and y so I can find my a. And whenever you're given the opportunity, try to pick a point that has 0 in it to make the arithmetic easier. I'm going to use this for my xy point. So I have y is equal to a x minus h squared plus k. I have everything I need except for my a. I'm going to plug everything in. I'm going to use my negative 6 for y. I'm going to use 0 for x. My h is negative 2, so that gives me a double negative, which is a positive. And then my k is also negative 2. So I have all of this information, and I can solve for a. So inside first, I have 0 plus 2, which is 2. 2 squared is 4. So I have negative 6 is equal to 4a minus 2. So if I finish this up here, I'm going to add 2 to both sides. So I have negative 4 is equal to 4a because I added 2 to both sides. And then I divide both sides by 4 to finish solving for a, and I get negative 1. So my standard form is going to be -1 for A, x plus 2, because my h is -2, and I have a negative, makes that a positive, and then I have my k is -2. So here's my equation in standard form. We found my vertex, and then the last thing we have to do is find the axis of symmetry. And the axis of symmetry is that vertical line that comes up through the vertex to split the graph in half. So, since that point is at -2, -2, and I know my vertical line has an equation x equals, it passes through -2, so my equation for the axis of symmetry is going to be x is equal to -2. Okay, 2 more examples of finding an equation. It says write the equation for a quadratic function that contains the given point and has the same shape as the given function. So it contains a point -1, 0. So that's my x and y. My a, it's telling me that my a is 2. And it's also telling me that my y, the vertex is on the y-axis. If my vertex is on the y-axis, then that means my x-coordinate of my vertex is 0. So that's telling me that h is 0, and I just have to find my value of k. So it's giving me the information in a roundabout way, but it's giving me everything I need to find my standard form. Here's standard form. This time we know what our a value is, it's 2. We have a point for x and y. We have our value of h, so the only thing we need to find is k. So I'm going to plug everything in except for k because we don't have that, and that's what I'm going to look for in this case. So I have y, which is 0, right? This is my point, my extra point for x and y. I have my a, which is 2. I have x minus 0, which I can just leave as x. If you want to put in the -0, that's fine. This is squared plus k. And now I have to solve this for k. So, let's see. Oh, I forgot to put in -1 for x. That's what I did. See, I make mistakes too. So if I take -1 and square it, that gives me a +1. And I have a +1 times a 2, that gives me a +2. So k is going to be -2. So when I put all those pieces together, I get my formula, or my equation in the quadratic is y is equal to my value of a, which is 2, x minus 0, because h is 0, squared, and then my k, which is -2. Okay, last question. It's giving me that my a is -5. It's giving me a point xy. And it's telling me that my vertex has an x-coordinate of -2. So again, we have to find the value of k, but we have everything else. Here's our standard form. So I'm going to plug in my value for x, y, h, and a and figure out what my k is, so then I can write out my final answer. So my a is -5. My y is 1. My x is -1. My h is -2. So when I have x minus h, which is x minus a -2, that's going to make it a +2 because of the double negative. And then I have plus k. This here gives me a +1. Square it, it gives me a +1 again. And +1 times -5 is -5. So this whole thing cleans up to be -5. And then I add 5 to both sides, and I get k is 6. So my final answer is going to be -5. That's my A. X minus h, which is a minus minus. So it's a +2 plus 6.